In this video, we're going to look at a couple more review questions. So what's the coefficient of x to the fourth in that Maclaurin series? Well, first, remember, you can always find the first four derivatives and figure it out. But remember that e to the x is approximated by this Maclaurin series. So negative x over 2, every time we see an x, we replace it with negative x over 2. So we're to x cubed now. Here will be x to the fourth. Okay, so let's just pluck this term. Let's just look at this one. So it'd be negative x to the fourth over 2 to the fourth over 4 factorial. So the coefficient, no, excuse me, it'd be positive because of being to the fourth. So x to the fourth, this would become over 16, and then that times 4 factorial. So 16 multiplied by 24. So it would be 1 over 16 times 24 would be that coefficient. Okay, so we can just plug in, because it was Maclaurin, into this series that we know. All right, finding the interval of convergence. Well, you'd set up ratio test here, so we'd have n plus 1 factorial times x minus 3 to the nth, n plus 1, excuse me. You'd have n factorial and x minus 3 to the nth. We're taking the limit as n approaches infinity. We have one more x minus 3 on the top. We end up with an n plus 1. Okay, so let me kind of put this up over here if I can. I have this x minus 3 I would yank out front. I still am taking the limit as n approaches infinity of what's left inside, which is n plus 1. I want this to be less than 1. Well, this limit right here is infinity. So I end up with x minus 3 multiplied by infinity has to be less than 1. The only way to do that is if x is actually 3, because then it would be 0 times infinity. So there's not really an interval, it's just one number that's going to work. Okay, finally, find the Taylor polynomial of order 3. So order 3 means third degree. Okay, so I'm going to need to have 3 derivatives. So let's start. The function is 1 plus x to the 1/2. So f prime would be 1/2, 1 plus x to the negative 1/2. Second derivative would be negative 1/4, 1 plus x to the negative 3/2. And the third derivative would be 3/8, 1 plus x to the negative 5/2. Now we're evaluating all of this at 0, x equals 0. So it makes it pretty easy, I guess, because 1 plus 0, square root of that's 1. This will be 1/2. This will be negative 1/4. This will be 3/8. Okay, so I'm going to have 1, 0 derivative over 0 factorial, x minus 0 to the 0. Plus, first derivative, 1 factorial, x minus 0 to the first. Second derivative, 2 factorial, x minus 0 squared. And third derivative, 3 factorial, x minus 0 cubed. We could clean it up. We'd have just 1 plus 1/2 x minus 1/8 x squared plus 1/16 x cubed. And there's our third order Taylor polynomial.